Hello friends, this video on Ray Optics Part 12 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till Part 11 before going ahead with Part 12. So now let us switch to image formation by a convex mirror. Now that you have understood the basic logic, that is how do we get the image formation, how do we draw the ray diagram to find out the image formation by a concave mirror, I think you yourself can also try the same with a convex mirror, and I'm sure that you will be able to do that. But anyways, right now we will study about this. So let us consider the first scenario where again we assume that the object is at infinity, but now the object is placed in front of a convex mirror. So convex mirror is a diverging mirror. That means the ray of light which will fall on the convex mirror, they will always have a tendency to diverge, right? So let us consider this scenario where the object is at infinity. So now according to one rule, let us suppose there is one ray of light which approaches the pole of the mirror obliquely, and then again it goes back obliquely. Now again, according to another rule which says that there is another ray of light which falls on the spherical mirror such that it looks like as if it is passing through the center of curvature, then after reflection it retraces the same path. So now here if we take this on this side, what do we see? They meet at this point. So that means the image is formed here. So this is my image A dash B dash. So now we assume that these two rays are parallel because the object is at infinity, so we don't know from where exactly these rays are originating. So what do we see about this object here? We see that the object is erect. It is obviously a virtual object because the rays are not actually meeting at this point. They appear to meet here, right? And also we see that the object is diminished. And most importantly, the object is formed on the other side of the mirror. So object is on the left hand side of the mirror, but the image is formed on the right hand side. So that means the image is formed on the other side of the mirror. Now let us look at the second case where the object is placed anywhere between pole and infinity. So now in case of a concave mirror, we discussed about each location separately. But here we are just discussing any location between pole and infinity. We are not specific about center of curvature, focus, this, that and all. Why? Because here if you see, the behavior of the image will remain the same. Everywhere it will be a virtual image that will be formed. And moreover, here if you see, the focal length, the focus, the center of curvature, everything is virtual here. For example, the principal focus in case of a concave mirror was a real principal focus. So an object can lie on the principal focus. But in this case, the principal focus is a virtual principal focus, right? So the object cannot lie at a principal focus. So there is no real principal focus. There is no real center of curvature. So the object cannot lie at those points specifically. So the object can just lie at any points. So we are saying that the object, first we assume that the object is at infinity. Now we are assuming that the object is at any of the points between the pole and the infinity, right? Got it. Okay. So now here again, let us suppose that a ray of light parallel to the principal axis, after reflection, it will get diverged, but it will appear as if it is passing through the principal focus, right? Another ray which approaches the pole obliquely, after reflection, it goes back obliquely. So if we try to join this virtually, we see that an image is formed here. So here also if you see, this was the object AB. So the image is again virtual, erect, diminished. So it is a general characteristic of convex mirror that the image is always virtual, erect, diminished. And what about the location of the image? Formed on the other side of mirror. Now since the image formed by a convex mirror always have these properties, that is why convex mirror finds its application in rear view mirrors of your vehicle. Because when you are driving a vehicle, the rear view mirror which you have on your side, that basically shows you the entire traffic behind you. So that means, see, the traffic behind you is huge. So you want to have a diminished image of the entire traffic. So that means you want the image to be diminished. You also want the image to be erect. You don't want the vehicles to be shown upside down, right? So you want erect image, you want diminished image, right? And you also want to view the image. So the image has to be formed on the other side of the mirror. As I told you before also, if the image is formed on the same side, if the image is formed behind you, you will not be able to see it. So the two important things because of which convex mirror is used as rear view mirrors in your vehicle is that it gives diminished image and it gives erect image, right? So I hope that now image formation by both concave and convex mirrors are clear to you. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.